This is a lesson on factorization. Factorization means writing as factors. For example, 3x plus 6 is written as the factors 3 times brackets x plus 2. This result is known as the factorized form, and the original form is called the expanded form. Here we will look at the different types of factorization: common factors, group factorization, using formulae for perfect square and difference of two squares, and the trial and error method. We begin by taking a look at the common factor. In the first example, we first look at the numbers. The numbers have a common factor of 2. Next, we look at the terms of A. A is common, and B. Once we have taken out 2 from 4, we left with the factor 2. We have taken out AB, leaving behind C. The sign is still the same. And we have taken out 2AB, leaving us with the factor 3. Similarly, we have 6B is a common factor, and taking out 6B, we should have 2 terms in brackets, since there are 2 terms in the question. As we have taken out 6B, what remains is the factor 1. Taking out 6B from here left us with AB. In the next example, we have square terms. We first look at the number. 5 is a common factor. We look for the lowest power of x, and that is the common factor, and the lowest power of y, which is y squared. And the terms we have in brackets is x squared minus 3 plus 4y squared. In the next example, we have a common factor which is an expression in brackets. We take out this common factor, and what remains is 2x minus y, which we enclose in brackets. In the next example, we have common factor in brackets as well as the other factors. We first look at the numbers. The common factor is 3. Next, the A term, lowest power is A, and the common factor of A plus B is A plus B. Once we have taken out A plus B and 3A, what remains is 2A plus 3 bracket A plus B. We need to simplify this further. By opening the brackets, the round brackets within the square brackets. We have 2A plus 3A, giving us 5A plus 3 times B, 3B. In the last example, we have a common factor of 7 to the power of n. We rewrite this as 7n times 7 squared minus 7n times 7 to the power of 1. And finally, we have 7 to the power of n times 1. Now we can see that 7 to the power of n is the common factor. So we take it out, and what remains is 7 squared, which is 49, minus 7 plus 1. The result is 7 to the power of n times 43. We next take a look at the factorization by grouping. In this case, we usually have 4 terms, and each group has a common factor. When we do these sums, we need to pay attention to the middle sign. In this case, the middle sign is positive. We factorize each group. The first group has a common factor of a. The sign in the middle is positive, so we bring it down. And in the second group, we have a common factor of d. Once we have factorized the common factor from each group, you should notice that there is a common factor in brackets. Thus, we take out b plus c, and what remains is a plus d in brackets. Similarly, for the second example, again we have a as the common factor plus d is the common factor, and once again we have a common factor in brackets, that is b minus c. Leaving us a plus d in brackets. We must now pay attention to the last 2 examples. In the first group, we have a common factor of a, giving us b plus c in brackets. Now the sign in the middle is negative. We need to put a negative here, and the common factor here is d. Now what remains in the brackets should be the same as the first term in the brackets, which is b plus c. Thus we have b plus c is the common factor and a minus d in brackets. We must take note that when the sign in the middle is negative, then we are factorizing out a negative term. But when the sign in the middle is positive, we should be taking out a positive term. Similarly, for the last example, a is a common factor and b minus c in brackets. The sign in the middle is negative, so we are bringing out the common factor, negative d. And what remains in the brackets should be the same as the first part, so it must be b minus c. Now we will take a look at some examples. Factorizing the first group will give us a bracket b plus c. Notice that there is already a b plus c in the rest of the terms. Therefore, the factor here is 1. B plus c is common, and the remainder is a plus 1. In the second example, a is common. Taking out a will give us a plus ab plus 1. The sign in the middle is negative. We bring out a negative common factor, which is C. And what we have in brackets must also be AB plus 1. In the last example, 2C is common. Taking out 2C, we have 2B minus C in brackets. In the second group, 3 is the common factor. The sign in the middle is negative. And we should have also 2B minus C in brackets. Factorizing out 2B minus C, we have 2C minus 3 in brackets. We will now take a look at factorization of perfect square. First, we must know how to identify a perfect square. A perfect square has positive squares at both ends. And you would also notice that the middle term has a 2, meaning that it is even. It's usually even. To factorize a perfect square, we only depend on the first and the last term. The first term is a squared, therefore we have a times a. The last term is b squared, so we have b times b. And since we have positive throughout, therefore both must be positive. And since these are identical factors, we can write it as a plus b brackets square. Let us take a look at the second example. Once again, we look at the first and the last term, which are positive squares. To get the first term, I have x times x. To get the last term, I have 5 times 5. Now, the sign in the middle term is negative, meaning that I should have both negatives for my factors. Again, we have two identical factors, so we write it as x minus 5 brackets square. We'll now take a look at further examples. Again, we always look at the first and the last term. The first term is x times x, and the last term is 3 times 3. And since it's all plus, both will be plus, giving us x plus 3 brackets square. Now, you may be wondering, what about the middle term? Once you have determined the factors, you can actually check for the middle term by multiplying across like this. 3x plus 3x, which gives us 6x. In the next example, we have the first term is 4x squared, therefore we should have 2x times 2x. The last term is 9y squared, therefore is 3y times 3y. And the sign in the middle is negative, meaning both must be negative, giving us the answer 2x minus 3y squared. In the last example, the first term is a squared b squared, therefore we have ab times ab. Last term is 9, which means 3 times 3, and middle term is negative, therefore both factors must be negative, giving us ab minus 3 squared. We'll now take a look at factorizations of perfect square. Now we remember that in expansion, when we multiply the first term times the first term, we have a squared. And when we multiply the last term minus b times b, we get a minus b squared. And what happens to the middle term is a negative ab plus ab, giving us a 0. So what remains is only the first and the last term, which is what is needed for our factorization. To get the factors of the first term, we take the first term times the first term. And to get the factors of the last term is b times b. And to get a negative, we need a negative times positive. In the second example, we can write this as a squared minus 9 squared, so that we have a difference of 2 squares. And this will factorize again to a factor that is negative and positive. First term, a times a. And the last term, 3 times 3. We now take a look at further examples. 25x squared minus 4. This will factorize to 25 is 5 times 5, and x squared is x times x. 4 is 2 times 2, and to get the negative is one side negative times one side positive. Similarly here, to get a 9m squared is 3m times 3m. To get a 4n squared is 2n times 2n. And to get the negative sign, 1 minus and 1 plus. In this example, we have a power of 4. It is still a square term. The factors are a squared times a squared to give us a to the power 4, and b squared times b squared to give us b to the power 4. Again, one side is negative, the other side is positive. Now we need to continue the factorization because we have a difference of 2 squares. So it gives us a minus b times a plus b times a squared plus b squared. Notice that a sum of squares cannot be factorized anymore. In the last example, we have 4a squared minus brackets a plus 2 squared. This is also a difference of 2 squares. The first term is 4a squared, that is 2a times 2a. And the last term is a plus 2 squared, so we have a plus 2 times a plus 2. And again we have one side is minus and one side is plus. We need to simplify the terms in the brackets. 2a minus a is a. Minus times plus is minus 2. 2a plus a is 3a plus 2. This is the final result. In the last step of factorization, we have factorization by trial and error. This is done somewhat in the same way by looking at the first term and the last term to determine our terms in brackets. 6a squared has factors 2a times 3a, and 3 has the factor 1 and 3. Do we put the 3 here, or do we put the 3 in the other factor? The obvious choice is to put 3 in this factor, because if there is a common factor of 3 in brackets, it means that there is a common factor of 3 throughout the terms. But we notice that 7 does not have a factor of 3. Therefore, we cannot have the factor 3 in brackets. Therefore, this must be a 1. Notice that we did not take the sign into consideration. To determine the sign, we must figure out the middle term. To do that, we multiply across to give us 9a, and multiplying across here will give us 2a. What we need is a positive 7a, and to achieve this, this must be a negative. Therefore, this term here must be negative, and this term is positive. That completes our factorization. We now take a look at further examples. We go through the process again, taking the first term and the last term. The first term is 4m squared, so we have 4m times m. And once again, we cannot put a 4 here, as there is no common factor of 4 throughout. Therefore, we put a 3 here and a 4 here. And since all the terms are positive, our factors are also positive. To ensure that we have done our factorization correctly, we need to check the middle term, which is 3m and 4m, giving us a total of, this is 16m, giving us a total of 19m. In the next example, 8a squared has factor 2a and 4a. And for 9, it has factors 3 times 3. Again, we need to check the middle term before we can decide the sign. Here we have 12a, and here we have 6a. Since the middle term is negative 18a, both must be negative. It is also important to check the sign in the last term, which is positive. So we have negative times negative to give positive 9. In the next example, we notice that we have an x cubed term. We can only factorize x squared terms. Therefore, there must be a common factor of x. Thus, we have to bring out the common factor first, so that we will have the x squared terms in brackets. And factorizing this, we have x minus 4 times x plus 3. The middle term is negative x. We have negative 4x plus 3x to give negative x. Thus, we must remember that before we can factorize, we should always take out the common factor. In this case, is 2. And the term in brackets, we have x squared minus 9x plus 14. And factorizing this, we have the factors x times x, and 14 is 2 times 7. And to get a negative 9x, we have negative 2x minus 7x. Let us now take a look at some more examples. It is important to identify which type of factorization we should use for each sum. In the first case, we have a difference of two squares, and we know that when we factorize a difference of two squares, we will have a negative and a positive factor. A square times B square is simply AB times AB, and 1 times 1. The middle term is 0. In this case here, we have a positive square at both ends. So this is quite likely to be a perfect square. Using the first and the last term, the factors of the first term is 2a times 2a. Factor of the last term is b times b. Middle term is negative. Therefore, we have the perfect square 2a minus b bracket square. We can check the middle term. Minus 2ab minus 2ab will give us minus 4ab. Next, this is a factorization of by trial and error. The factor 2x squared is 2x times x, and 15 is 3 times 5. And we have to decide whether to put a 5 here or the 3 here. Suppose I chose a 3 here and a 5 here. Then we need to check the middle term, which is, in this case is 7x. Thus we have 3x here, and on this side we have 10x. Since we need a positive 7x, this must be positive and this must be negative. 10x minus 3x is 7x. In the next example, we notice that these are not squares, but on careful examination, you will notice that there is a common factor of 3. Taking out the common factor, then we can see a difference of two squares, which will factorize to 2n minus 3 times 2n plus 3. In this example, we have a common factor of 2. Thus, we factorize out the 2 first before we factorize any further. And on careful examination, you notice that it could be a perfect square because we have positive squares at both ends. Thus, we have the factors 3x times 3x to give us 9x squared in the first term, and 4 times 4 to give us the last term. And since the middle term is negative, both must be negative. Thus, we have the answer 2 times 3x minus 4 squared. The next example is a difference of two squares. For the first square, 4m squared, we have 2m times 2m. And the second term, we have n times n, 1 minus 1 plus. In the last example, this is similar to the previous sum. This is 4m squared and this is 4a plus 2 squared. To get 4, we multiply 2 times 2. And just as to get m squared, we multiply m times m. To get a plus 2 squared, we have a plus 2 times a plus 2. And for the last term, a plus 1 squared is simply a plus 1 times a plus 1. And one side is negative, one side is positive. And opening the brackets, we have 2a plus 4 minus a minus 1. And here we have 2a plus 4 plus a plus 1. And simplify this, we have our answer 2a minus a is a, 4 minus 1 is 3. 2a plus a is 3a, 4 plus 1 is 5. Now we will take a look at how we use factorization in numerical calculations. We will be making use of these two formulas, a square minus b square, which is a difference of two squares, which give us a minus b times a plus b. And the next formula is a perfect square, which factorizes to a plus b times a plus b, which is further simplified to a plus b squared. The first example is a clear-cut difference of two squares. Thus, we factorize it to 3.2 minus 1.2 times 3.2 plus 1.2, which gives us 2 times 4.4, and the answer is 8.8. In the next example, if you look carefully, this is 300 plus 2 and this is 300 minus 2. This is simply the terms a minus b times a plus b, which will expand to a square minus b square. So here we have 300 square minus 2 square. And expanding this and simplifying, our answer is 89996. In the next example, we have a common factor of 295. Bringing out the common factor 295, we have in brackets 3.5 minus 1.5, which is 2. 3.5 minus 1.5 is 2. 2 times 295 is 590. In this example, this is a perfect square. Thus, we are looking at the second formula. We rewrite this as 900 plus 1 bracket square, which means 900 plus 1 times 900 plus 1. And expanding this, we have 900 square plus 900 plus 900 plus 1, which is 900 square plus 1800 plus 1, giving us the answer 811,801. In the last example, it gives us a perfect square. The first term and the last term are positive squares. To factorize this, we look at the factors of the first term, which is 98 times 98. And the last term is 2 times 2, and it's all plus. Therefore, what we have is now 100 times 100, which gives us 10,000. This completes the lesson on factorization. Thank you.